Okay, this is just a simple test. The video will start in probably in 1 more minute. Just testing sound and video and see if it's working fine. It seems that sound seems to be working fine. We'll see once people start to arrive. You can type in the comments if you can see and hear me well. It is gonna be really helpful. Perfect. So we have sound, we have video, and I'll just wait a few more seconds for people to join. Okay, so this particular video is in YouTube, so the reason is so the recording can be available to anyone can come here and see it. It's kind of part of the YouTube channel collection that I have for all the tools, and I think that the ultra neural net deserves its own video, in particular for those of you that used to follow the original ones. So thank you for attending, and let's start right away because I don't know how long this will be. I might have to split this into a couple videos. So the title of the presentation is Neural Nets and Probability Distributions, or an Introduction to Psychohistory. And that's just a joke, for those of you that like science fiction and get the reference. So let's see what we have. The ultranet is just a convolutional net. Is a deep learning net. It uses very advanced mathematics and it's a very complex net. In a sense, it's very complex, And we have used them for a long time, since the incarnation of the NDLA, then the Ultra 4, what I call the Ultra 4 now. Ultra something, I forgot the name of Ultra. So I just call it Ultra now. No, that's the current name. So basically it's just a deep learning net. This neural net has a peculiarity. Most of the time we use machine learning to find patterns, to for instance, give it pictures of objects, and the neural net can classify the objects into, I don't know, animals, cats, elephants, things like that. And that's how we were using Ultra. Ultra was a classifier that was looking for a particular event in the market. In this case, Ultra was looking for 1% move up in 5 days. And it was more or less successful. But the problem is he generated very little predictions. Now, once in a blue moon, it will generate a prediction. And also if the market had extreme volatility, then it was useless because 1% is nothing. When the market is really volatile, it moves 1% in 10 seconds. So having a neural net for this is kind of redundant. Like, you don't even need a neural net to predict a 1% move if the market is crashing. It will happen all the time. It's a bounce. So in this case, I decided to modify Ultra to find a probability distribution. So Ultra is not looking for a pattern. Ultra is not looking to tell me that this is a cat or an elephant. Ultra is telling me a conditional probability for the distribution of log returns in the market. That's what it is. And the nets now, the current nets, are returning a mean and a standard deviation. That's what it is. The only two values that Ultra returns is just two little values, a mean and a standard deviation. For those of you that are familiar with statistics, you know that that's the only thing you need. You don't need anything else. With those two parameters, you can describe a normal distribution, and you can go crazy with that and do infinite number of traits. Okay, so this slide is just to set up what the presentation is going to be about. Of course, I know that most of you are not familiar with the statistics of probability, so it can help to provide a little background about this. So this is the example table. This is how the new Ultra looks like. For those of you that know me, you know that I like tables. I don't know why I like tables. Some people don't like tables. They prefer to present information in a different way. So I am just presenting a table, and the table seems really complex, and the table seems to have all sorts of information. But at the end of the day, the only two important parameters from this table are the last two columns, the mean and the SD, or standard deviation. That's the only thing you need to know. Those two final parameters, I don't know in the resolution of your monitor you can see it here, is the only thing you need. Let me do it from the website, so maybe it looks better from here. Let's see if it looks better from here. So maybe from here the mean and the standard deviation are easy to identify. So these two values at the end. No? So that's the mean and the standard deviation. And with that, every single value on the table, everything that I show in this table, everything, this probability, this other probability, everything is computed just using those two. So basically everything else is redundant. The only thing you need is the mean and standard deviation. The only reason I am showing everything else is because it's kind of quick. No, you can quickly glance at this and see things quickly. But if you only have these two values, you can recreate the full table. No. And what is the structure of the table? From this table, the table shows a date where a prediction was made and a target date for when the prediction is valid. No, that's kind of the standard. From all of the information I showed, we are only interested in the first row of this table. Just this first row. The first row is the only thing important, because the first row is what is happening today. This is what is happening today. Those values change during the session. Those values are constantly changing. So you could ignore anything else on the table. I could have only, if I wanted to, I could only show this first row. But I decided to show the other rows because, you might be curious about past predictions. So I am showing past predictions that will never change. Those values that you see on those past predictions will never ever change. Okay, so it's something important. Don't get confused with the table. If you don't like to see that many numbers, just focus on the first row. The first row is the most important one, is the one that is happening today. No, and then for tomorrow you'll notice that will become the second row, and those numbers will be fixed forever and ever. No, that's how it works. So the structure of the table is very simple. It's nothing to be alarmed. And the important thing is that we have mean and standard deviation. That's the most important thing from the prediction. Okay, so what are the mean and the standard deviation? How is that useful? How can that help us do anything? So I'm going to explain briefly what a probability distribution is. Probability distributions are very useful when the phenomena we are dealing with is random. Okay, when the phenomena is so complex that you could think about it as a random thing. Okay, so in random phenomena we can never think about certainties anymore. We start thinking about probabilities. To us, the probability is the king. We are doing probabilities of anything. That's the only thing we can say. We don't say, oh, the market will be at this value 1 week from now. That's impossible. Okay, no one can predict that. The stock market, the S&P 500, is a random system. No, how can we predict something that is random? But even if it's random, we can use techniques that allow us to describe it, and this is very important. Even though the S&P 500 is truly stochastic, and this is a discussion that I used to have in the main room all the time, because I know some people think that it's not random, it's deterministic, it's just that we don't know what the function is. But I'm telling you, it is pointless to look for a function. The S&P 500 is a stochastic, period. As it's easier to live with that. It's easier to think about the market as a pure random function, and that has interesting properties. Okay, for instance, in order to say this more exactly, well, the random variable is not the price of the S&P 500. The random variable is the log return of the S&P 500. Log returns are really stochastic. They exhibit interesting properties. The log returns exhibit very, very interesting properties. The log returns are autocorrelated, and this is a very fancy word to say that the log return of one day seems to have the influence for near-term log returns. So in other words, this is something you have seen all the time. When the market is very volatile, when the market moves a lot, it tends to keep doing that. Now, see, if the market is oscillating in big jumps from day to day, it keeps doing that. And conversely, if the market is moving very little, it's really calm and nice, it tends to stay that. So the market tends to be autocorrelated, where the behavior of the past days more or less could be extrapolated to the behavior of the following days. Now, if we have experienced high volatility, high moves, really the market moving a lot up or down, then we should expect that in the near term, and vice versa. So that's what autocorrelation is. It's a very well-known phenomenon, and it could be exploited. No, it could be exploited, even though it's still random. We don't know exactly the value. The autocorrelation is giving us a hint about the standard deviation of the moves, and it helps a lot. And what Ultra does is doing that. It's looking for those autocorrelations and seeing how the market is moving. So there are many ways to describe random distributions. The most popular one is the Gaussian, and Ultra right now is Gaussian. I could have picked anything. There are thousands of distributions, I will say. If you go to the Wikipedia page, you could go crazy just looking about distributions. So the normal distribution is, to me, is the most simple one. It's a distribution that can be represented only with two parameters. That's the only thing we need to represent in a standard Gaussian distribution, or also called a normal distribution. And the two parameters that we use one is the mean of the distribution, and the other one is the standard deviation of the distribution, or sigma. It's a Greek letter, sigma. And you see the shape. The shape of the distribution is very interesting. But this is what you're seeing is the probability density for any value on the distribution. So the mean is at the center. So the probability of seeing a value near the mean is very high. As you can see, there is like the peak, no? And then as you move away from the mean, either to the left or to the right, the probability decreases dramatically. Now, it's almost after 3 standard deviations from the mean, the probability of seeing any value in that area is almost 0. No? So the normal Gaussian distribution has a very interesting rules, and the rules are that most of the values are seen around the mean plus or minus the standard deviation. And this is around 68%. This is the Chebyshev rule. I didn't put it there, but for you statisticians, it's called the Chebyshev rule, and it applies to any distribution. No, so that means that if I have a value, if I have a distribution of log returns, I should expect to see 68% of the time to find a log return between the mean minus 1 standard deviation and the mean plus 1 standard deviation. There is also the 95% rule, or the 2 sigma rule. In a Gaussian distribution, we expect to find 95% of all of the possible log returns between the 2 sigmas. You see it here, mean minus 2s, mean plus 2s, so it's 2 sigma. So it's very interesting because we don't know where the market will be next week. We have no idea what value exactly will close 1 week from now. But if we use a Gaussian distribution, we can have a range of probabilities. We start playing with probabilities here. We can see, okay, we could look for a 95% interval where we say, okay, with 95% confidence, we think that the market is going to be in this range. Okay, that's one way to trade it, no? And I'll show it later on how to trade it. So this is a normal distribution. It's just a probability. It's a nice, beautiful shape. And the funny thing is that shape is described by a very simple equation, but the probability is actually the area under that curve, and that area is almost impossible to compute. It's probably one of the toughest problems in mathematics. It's because there is no one knows if there is a solution to that problem. It can be computed with computers and by hand. In antiquity, people just basically spend all his time computing the possible values. Like there will be people only computing by hand the values of this probability because it's impossible to solve analytically. It needs to be solved numerically. Anyway, it doesn't matter because we have computers that do this for us nowadays, no? So we don't have to worry about a poor monk in a monastery in Germany just spending 20 years of his life compiling the table of the probabilities. I wanted to show you that the distribution, the shape of the distribution depends only on the standard deviation, sigma. You can see here that if there is no standard deviation, if sigma is 0, then there is no distribution. There is only one possible value. No? There are no probabilities. But if you change the value of sigma, you get different shapes. No? You notice that the distribution is very narrow and it starts becoming wider and wider and wider. And the mean, it really doesn't change the shape. The mean of the distribution is only changes what position it has on the x-axis now. So most of the time we assume the mean to be 0, and then from there we start. But the thing that really changes all of the probabilities is the standard deviation, is sigma. Sigma is one of the most important parameters. Funny thing is that in the financial world, in the market, the standard deviation of log returns is what we call volatility. So it's just the volatility of the market is the most important parameter for the probability distribution. If the market has very high volatility, well, that's because it has a higher standard deviation, and then the potential probabilities for where the market will be in a week is going to be really wide, not like the purple line. It's really going to be really super wide. But if the market is very calm and nice and volatility is really low, then the probability distribution becomes really narrow, so we can say that the market will be in a narrow range. No, that's how it works in terms of the Gaussian distribution. And quick mention, the market for the longest time, and all of the option theory has always assumed that the market is Gaussian. Now it follows a normal distribution. We know for experience, and we know because we can observe it, that the market is not Gaussian. Okay, so the market doesn't follow a Gaussian distribution, and then you'll say, okay, so what are you doing a neural net that computes a Gaussian distribution if the market is not Gaussian? And I'll say, yes, that's a great question. And the reason is, what I say is that we cannot find a single distribution that captures the market. So if you take the whole history of the market and you try to find a beautiful shape that captures all of the log returns since the creation of the S&P 500 until today, it will be impossible. It's not Gaussian, it's not normal. It doesn't follow a Gaussian distribution. But notice that that's not what Ultra is doing. Ultra is not finding the Gaussian distribution of the market, the ultimate truth that everyone is dying to find. Ultra is finding only a particular distribution for 5 days from now, and it's changing all the time. If you look at the table right here, you can see that the mean and the standard deviation are completely different. No? So what Ultra is doing, Ultra is actually finding infinite Gaussian distributions. So that's what it works, because Ultra doesn't care. I mean, we are not really looking for the ultimate source of truth of the market because it doesn't exist. But what we want is the distribution for 5 days from now. If Ultra can find an approximation to that distribution, and we can find it, because then tomorrow will be different, and you can see on the table it is different from day to day. Okay, so that's what Ultra is trying to do. Okay. And by the way, I'm going to open the floor to questions at this time. So remember, this will be recorded forever and ever, but you can type the questions in the chat window in YouTube if you want. So I want to pause a little bit to kind of vacate a few questions, if anyone has questions. I have a question that says, how do we measure the success rates of the MP1, T0, T1? I mean, how good is this net in predictions other than to sigma range, which you already clarified as 96%? Well, so I don't know how to answer the question. I mean, the neural net is giving you probabilities for these things, and these probabilities are normal, so they are as accurate as the normal probability for those values. No, we can see later on. It's like, if the probability is telling you that there is 60% odds of seeing P1, that's what it is, 60%. No, probably a little higher than 60%. So we have to think about, there is no accuracy. It doesn't, okay, I see where the question is going. It's because in the previous nets, we used to have accuracy and precision. But accuracy and precision are only concepts that are valid for classifiers, no? If I have a classifier that tells me this is a cat or this is not a cat, no? Then for that, yes, I can see how accurate it is to predicting if this is a cat or not. So we can see the prediction, how accurate the prediction is. For ultra, it makes no sense because that's not what ultra is doing. Ultra is predicting the distribution. And from the distribution, as long as the distribution is normal, then that's what you should expect. And the distribution is very normal. And the ultra is actually very accurate. It's a little better than a normal distribution. Ultra is actually fitting really well. So I will say that for all practical purposes, you should assume that the probability that you see there is the correct probability. So that's how we should proceed. And I'll show how to structure a trade based on that, no? Because that's the big question. That's how we compute the edge. In the case of the classifier, then we use the precision to figure out what is the edge of the trade. But in the case of a probability distribution, we don't use the precision. We use the probability from the table itself. I have another question. How similar is this new net as compared to Luke's Bayesian probability system? I have no idea. I don't know how Luke's system works. I think it's a proprietary system. I don't know. It might be that we are doing exactly the same thing. I don't know. It is an interesting question. I will say it should not be similar because as far as I know, Luke is not using convolutional nets. He might be using something else, but at the end of the day, it's all mathematics. And at the end of the day, you remember that a convolutional net internally solves a gigantic numbers of sets of equations. And it might be that the equations that Ultra has found are very similar to the equations he has found. No? The difference is Ultra only has 5 days prediction ahead. No? So it's not like a Bayesian system that seems to be longer term. And also Ultra has a probability distribution where we can evaluate not only the probability of going up or down, but the probability of specific ranges. Andrew has a question that says, I know we have established 10% intraday realized variance as a threshold for the end of the correction. Shouldn't we be able to gain a greater clarity by coupling those values with specific and declining SD values? Yes, that could be. If the SD column in the ultranet could be converted into volatility, really easy. The only thing you have to do is scale it, no? But the standard deviation parameter is the volatility of the market. And if you see it decreasing, then there's a great sign. No, it's a great sign that the correction might be over. So I'm switching here, and you can see that it is decreasing. You can see how standard deviation was 3.23 1 week ago, then 2.83, then 2.55, then 2.7, 194, 193. You can clearly see a trend of the predictions of a standard deviation coming down. Now, clearly, Ultra is thinking that the market is going to be less volatile than it has been in the past week. And I think that's a good sign. I think we could use, even if we don't use the exact numbers, we could see this trend as a positive sign in terms of volatility. I don't know if the market is going up or down. What it shows is that at least Ultra expects the market to be more calm, more civilized than it has been so far. Okay, I'm going to close the questions for a little bit to continue with the presentation. Well, very good questions. And then we'll come back at the end to this again. So let's start with computing probabilities. Okay, so now I have the mean and the standard deviation. What can I do with those things? So when you have those two values, you can do everything you want. No, you can do. The good thing about Ultra is that Ultra can answer any questions that you want. The problem with the previous nets is that they only answer one question. Now the previous nets only answer the question, is the market going to move 1% up? No, in this case you can do all sorts of interesting things. You remember that the distribution that the ultranet is using is the distribution of log returns. So the questions need to be related to log returns. No? And if the question is phrased in absolute S&P 500 levels, SPX levels, then you need to convert that into a log return first. But one of the questions is, you can compute the odds of seeing a particular value in the distribution, like a single value. Like you can compute the odds, okay, what are the odds that the market is going to move exactly 1% or exactly 2%, but only 2%, no 1.1, no 2.2, but exactly 1 or 2. That's called the probability density of the particular value. And pretty much every software, including Excel, Microsoft Excel, has that function. The thing is, I haven't used Excel in a long time, so I don't know what the name of the function is. It's probably something like normdist. Like they always use some kind of really weird naming convention for the density. It's like normal density or normal distribution. And you take three parameters. The parameter you want to evaluate, the mean and the sigma. So you can get mean and sigma or standard deviation from the ultra table. And then X is the question you are asking, and you can see the answer right there in Excel. You don't have to ask me. You could use Excel just to compute the function. Of course, computing the probability of a particular value is not very useful for trading in general. I mean, it's very unlikely that the market is going to hit a particular value, and it's very hard to structure a trade. In fact, for those of you curious about this, the only trade that uses these are butterflies. If you are doing a butterfly is a pure bet on the density distribution of the market. So if you have a butterfly in your head around, let's say, 3,300, no? Or 3,200 or whatever, then you can compute the density, the probability density, to see the probability of the market being at 3,200 at expiration. That's one useful. But if you are doing other types of trades that are not butterflies, then that's not useful at all. The more useful thing is the probability of ranges. This is where this actually becomes really useful, because with ranges, then we can do all sorts of interesting trades. We can compute the probability of a range from minus infinite to the value that you want. Of course, the market doesn't have minus infinite returns now, but that's what I'm trying to say. It's like, okay, what is the probability of seeing 2% or less? From 0 to 2%, I mean that range. I want to see what is the probability that the market stays in that range. And the good thing is it can be done. This is what is called a cumulative probability. So instead of doing a probability density, this is the cumulative probability density, not distribution, or distribution too. So this is the cumulative probability, and Excel again has it. And I think the Excel has it as a parameter, where you say the parameter to true if you want to see cumulative or not. So you can compute the probability of the market being in any range. It's very cool. So let's start looking at using the table for trades. So the table, okay, I have a question that is important to answer. It says, does the mean column correspond to the SPX column? No, the mean is the mean of the log returns. So the mean that you see is the expected mean of the return of the market. If you see 0. I don't know what it is right now. Right now it's like 0.17. It means that the expected mean is 0.17% return in 5 days. That's what it's looking for a return of 0.17 positive return in 5 days, in 5 sessions for next week. Yeah, and it's in log returns. It's a return. A return is the percentage of change between something. Okay. So let's look at the most basic trade, and this is one trade that has been already discovered by members of the room. No, I put this table saying how many trades could you discover. This is the most basic trade, and it's called the 2 sigma trade. No, so the 2 sigma trade is, the table shows 2 columns called +2 and -2. What that means is that's the 2 sigma range, and you remember the 2 sigma range is the range where we expect 95% of values to be within that range. In other words, we expect that 95% of the time the returns of the market will be in this range. And 95% is a really good, it's a great percentage of success rate. No? It's a trade that will work. It will work many times out of 20. For instance, it will work 19 times out of 20. No, that's what it is. Yes. 19 times out of 20. So it will fail once every 20 trades. So you can structure that a trade like that. So what is 3.92? It means that by July 16, looking when I created this slide, this was before the close. The market was a little higher before the close. Looking at this slide, you can see that at that time, Ultra is predicting that for July 16, it expects that whatever is the market is at that level, the return will be between 3.92 positive and minus 3.6 negative. And that's called the 2 sigma range. And the interesting thing is this tradable? Most of the time, yes, it is tradable. In the case of July 16, I don't know if it's tradable right away because there are no options for July 16. But if there were options, it is tradable. How do you trade these two ranges? Okay, so the only thing you have to do is to convert the log returns to absolute SPX values. And this is the most helpful equation that you will use. It's good that you take notes of these equations. They're very simple. You are using a function that is called exp. The exp function is one of the most important functions, and I know Excel also has it. I don't know if Excel has it, but it should have it. It's the exponential function. It's an exponentiation where the base is e, the base of the natural logarithms. So the upper value of S&P 500 is just you taking the current value, multiply the x function of plus 2 divided by 100 because the returns are already scaled by 100, and it gives you a number. It gives you that what Ultra is saying that when I did that prediction was that the market will be between 3,284 and 3,046. So it gives you right there a range. And what it's telling you is that there are 95% odds that the market, whatever is the closing value on the 16, is going to be between those two values. And you say, man, that range is kind of big, no? It's 240 points, but the range is not as big as you think, and there could be a trade there because you could create an iron condor. The most basic trade structure is an iron condor that captures those two values. For instance, if you do an iron condor with inner strikes of 3,285 and 3,045, it will capture these things and you'll be safe 95% of the time. And even though I hate iron condors, I hate them, I don't like iron condors at all. But if you can find an iron condor for this trade that is providing more than 25 cents in credit, then there is positive edge. If you see it at 25 cents, don't even try. It's zero edge. It's like a pure bet. You are just betting. But higher than 25, you are starting to have edge. Like you are actually playing a random game. No, we don't know if we are going to succeed or not, but we are playing a random game with good odds. It means that the options are not priced correctly for these things. And looking at what other members of the Gamma Optimizer room have found, it seems that it's consistently mispriced, the iron condor. My take on this is I prefer just to do the lower value trade. That's the one I prefer. The lower value, which is just sell a vertical put spread. And the reason is that the S&P 500, contrary to popular belief, because this is completely contrary to anything that everyone believes in the internet and outside, the market goes up. And this is something that you should realize. The market just goes up. And it has been the constant since 2008 or even high before that. The periods where the market comes down are very rare. Very, very rarely the market goes down. The market tends to drift up all the time. So in that sense, the lower range is the one that has better odds of succeeding. And ironically, the puts for S&P 500 are more expensive than the calls. So you will get more money for the lower value vertical spread than for the higher one. That's the irony. They charge more money for the event that is more rare. Okay, so it's interesting. I don't know why. That's one example trade. We have other trades. We have the P1 to P3 probabilities. So let's see. It's called what I call unlikely events. Let's look at an unlikely events here. So let's look at it in this table. So you notice that I have a set of predictions P0, T0, P1, T1, P2, T2, P3, T3. Those are just pre-computed probabilities for moves. You could compute them with the mean and the standard deviation, no? But I'm just doing the pre-computation here for you. It's just so it's easy to see. And this is the probability of seeing the target value or more. You see? So in this case, P0 is the probability of seeing 3,152 or more. P1 is the probability of seeing 3,183 or more. T2, 3,250 or more, and so forth and so on. No? You get the idea. So it's the probability of seeing the value or higher than that value. And the way I designed this is because then we can design trades for this. Right now there are not many trades here. So the only thing we know is that Ultra thinks that next week the market is going to close above 3,152, which is the closing value today. In other words, Ultra thinks that the market is going to be either at the same level or higher. No, so it's kind of neutral. It's very neutral, no? So 53% is like right there. It should be 50, it's 53. It's not that Ultra is extremely bullish into next week, but at least it's neutral bullish. And you could do a trade for this if you want. You could do vertical call spread, but I bet it's going to be really expensive. There is no much edge. The interesting thing is what happens when you start seeing high probabilities for these things. Those P1, P2, and P3. Right now, as you can see on the table, they have been really low most of the time. Now they have been kind of low. But even if they had been low, they had been fulfilled. And an example of this is, notice the prediction from last week. This is the prediction from last week, on July 1st, for today. And last week, the market was at 3,115. And Ultra wasn't very positive because it had a negative mean. Now, Ultra was looking at the market mostly with a negative bias. But notice that the market today closed at 3,152. That was the close today. So it will be between these two values. Notice here that the close today will be between these two values. And even though Ultra assigned, it didn't assign that many probabilities to it, there could have been a trade. Unlikely probably events happen, and you could make lots of money if they happen. Now they could be really profitable. The key is finding a trade that has positive edge. So we could have done a trade last week with 35%. It's not that bad for P1. It is more or less with historical behavior of 1% up, and this 2% up, and so forth and so on. So it's just keep an eye on this. I don't like to do those trades when the probabilities are this kind of low, but eventually you'll notice at some point you will see really high numbers here in P2 and P3 or P1. You will see like 60, 70. When you see a high number in any of those columns, we do a trade. You will see a trade from me. And those trades are going to be bazooka trades. Those are trades that are going to deliver gigantic returns because they are long gamma trades and they will be really cheap and they will deliver a lot of money. So just keep an eye on those unlikely events. So how do you play these things? Vertical call spreads. That's what you do. We play a vertical call spread as long as it's cheap. So cheap is lower than 2.5. To me, cheap is around $1, less than $1. But technically it's 2.5. If you see a value in those columns higher than 50%, we take the trade. As long as it's cheap. So you will say, okay, yes, I can see here on the table that we have 53 and 58 from yesterday and today, but I mean, it's too close and it's too expensive. It was like $2.5, $2.4. So that's, it technically is a trade, but yeah, I don't like those trades. If I see a 50% here in P3, forget about it. I'll take it. No, I'll get a second mortgage in the house and I'll play it. No, it will be a fantastic trade. For now, we don't have them. We don't have those trades yet. So, but that's how you use those things. No, you can also use these predictions to the opposite. If the predictions are really, really low, then it's the opposite. No, you'll say, oh, the odds of seeing this value are so low that maybe I could sell the call spread. But I don't like to do it because in SPX, selling call spreads is very dangerous. So here's an example of how to do a trade like that. let's imagine for some reason P2 is 60%. No, like for some, it is not right now, but imagine that it's a 60%. And T2 is a target, I don't know, whatever target. So then the play is very simple. The play is just a vertical call spread at 3,200. Why 3,200? Because we round the target down. Okay, I cannot click, I guess. We round the target down to the nearest strike, but down, okay? Because we want to cover the prediction. We don't want to run up because the prediction is not for a higher value. The prediction is for 2004 at least. So we go down to 3,200 and we do this vertical call spread, which is actually the opposite. Oh my God, I got the wrong. You buy 3,195, sell 3,200. I got it here. The short strike is 3,200. So this should be the short strike. So undo this in your eyes, change the buy to sell is the complete opposite. That's the trade on the way up. If it's priced really cheap, you're going to get lots of money on there. I mean, you'll get the $5. So you have to remember, you'll get $5 for this if you're correct. And so you can get it at 70 cents and you're risking $70 for 500, and you can get it at $1, you're risking 100 for 500. It's a great trade, no? But you have to wait until P2 is around that value. Okay, and then with this I'm going to open the floor once more just in case we have more questions related to this before moving up. So use the time to ask more questions. So basically what we have here is a system that will allow you to trade vertical call spreads or iron condors, or even vertical put spreads. I have a question. Is there anything wrong with using the mean and standard deviation to calculate the actual probability at 3,200? No, there is nothing at all. You can use it. I mean, it's just that the P2 was already computed, no? But yes, you could use the mean and the standard deviation to calculate the probability of 3,200 or more, and that's the trade. No, that's the beauty of having mean and standard deviation, that you can use anything. So instead of me creating a table with infinite columns, you can take the values and use Excel or any software that you like and compute these probabilities really quickly. Even a calculator. I bet that even the calculator in your iPhone can do this. I'm not sure, but you might be able to do this with a good calculator. There is so that question from Sam connects with this. There are custom trades. You can do custom trades. Okay, so I have a question from Richard. I am hung up on why SPX is equal to T0. Oh, okay. So let me switch quickly there and then we'll solve this mystery. So the question from Richard is that why T0 is always SPX? Well, it's very simple because remember, those are just pre-computed values for a move. What is a 0% move? P0 is the odds of a 0%. 0% move is that the market didn't move. So what is the target for the 0% move? Is the current value of the market, no? So that's why T0 is always SPX. T0 for any day, T0 is SPX because the P0 target is just the target that the market will be at current value or higher, no? A 0% move, no? Is the market didn't move, is like that. So that's why you see T0. And T1, these targets are not magical targets. These targets don't come from the neural net. These targets are just SPX 1% up. And this one is SPX 2% up. And this one is SPX 3% up. The only thing that you have to take in mind is that those are log returns. So it's not like the pure 1% return or the 2% return. It's the logarithm of the return. So it has to be 2 or 3. They don't align quite the same. In log returns, the upside log returns are actually higher than the normal log returns. So I have a question from Alexander. How often is P2 or P3 60% or more? It's not that often, but the table only shows the latest 5 predictions, but when I run this through all year long, I can see a few instances where they actually were really high. Like in March, you will see P2 and P3 lighting up all over the place. The one that is most likely to light up is P1. No, but there have been instances, and I guess it's all related to standard deviation. There are two ways that P1 or P2 could be really high. It could be that the mean is extremely positive. In this case, the mean is not that positive. The mean is usually it should be something low, but if the standard deviation is very, very high, right? Right now in the last week, the highest value has been 3.23. But if a standard deviation is something amazingly high, like 10, then P2 and P3 are going to be very big. The odds will increase dramatically. If you remember the graph where the distribution for high sigma is really, really big. So it's not often, but you'll see it. And you'll see it. It's often enough. I'll say that in the last year it has been, you should expect to see a P2 probably 14% of the time, which is more frequent than you think, because you have 252 days. So it's probably 20 values, around 20 to 25 times you expect to see this happening in a year. So I hope that's the... Andrew is asking the question, is the SD and mean computed purely based on options prices? No, the mean and the standard deviation are from the neural nets. There is no option pricing here. This is not from options at all. No, this is a neural net that uses a bunch of things, and option prices is not one of the inputs at all. So the mean and the standard deviation are the actual results of the neural nets. The other values are derived from the mean and the standard deviation. If you use Excel to compute the probability of 1% using this mean and this standard deviation of 0.17 and 1.93, you will get 33.3%. No, you'll get the correct thing. So I don't know why this thing is not highlighting. So this probability is computed from these two values right here. All of the probabilities are computed from the values, and the targets is very simple. The targets, as I mentioned, is just 1% or 2% or 3%. It's nothing magical about the targets. Okay, so let's finish this with custom trades. So we can use the mean and the standard deviation from that table to create any trade you want. Yeah? Anything. The only thing you need to do is to compute the cumulative probability for the value. And remember, the value has to be a log return. It cannot be this px value. So imagine that we want to do a trade for a fall. The market is going to fall. I don't know why people love doing these trades, but yeah, let's imagine that you want to trade that the market is going to fall 2% into next week. Okay? If we want to do the trade, we can do it. I'll challenge you to give me the answer with what you have. So the only thing you have to do is to compute the cumulative probability distribution of 2 with the mean. So remember, the distribution is already scaled by 100, so it's already in percentage. So it's 2 with the mean and the standard deviation. What is that probability? If anyone can run it quickly using the values from the table, 0.17, 1.93, and I can give you an answer. The probability from that, and let me switch so you can see the probability. I don't know if you can see this. Let's see. Okay, let's do the normal distribution of 2 base. So in R it's called pnorm, the function, but for your software it could be anything. And it's 0.17, 1.93. That's 0.17, 1.93. And I multiply times 100. So, it's actually the probability of falling, so -2. So the probability is 13%. So we have 13% probability that the market is going to fall 2% by July 16. And you'll say, okay, well, nice to know that, but how is that helpful to do a custom trade? No? Oh, yes. So I got a good answer already from Sam. How can we use that information to create a trade? So, well, you can use that information if you look for something. Let's imagine looking for let's look for put spreads for, I don't think that in the 16 we have any options, no? So in the 17 we have options. Let's look of something that does that. So let's get at the money SPX and let's compute what is the target for -2. It's 3090. Okay, so let's look for the 3090 strike. So a put spread to play that cost $1.1. Okay, so if we want to play that, it will cost us $1.1 to play that. And the question is that a fair price for what we are doing or not? No. So remember, the probability is 30%. So we need to compute, and this is something that I have here. So you price the spread for the probability. I don't know why this happened to me with this mouse. We compute the price of the probability and compare it with the percentage cost. If the percentage cost of the put spread is lower than that probability, then it's a good trade. And the percentage cost is just the cost divided by the width times 100. That's what you'll see in all your software. I mean, all of the Thinkorswim and everyone, that's how they compute the probability of being in the money. The only thing they are doing is just computing this percentage cost. There is no magic there. There is no probability. So let's do that quickly here. So 1.1 divided 5 times 100. So the put spread is 22%. Therefore, this is not a good trade. You know, that means that the put spread is priced at 22%. The odds of this happening is 13. If we play it, we are overpaying for this trade, and we don't want to overpay for the trade. You see? So already option dealers are terrible. No, option dealers are overpricing these things a lot. So that's not a good trade. But most of the time you can find really good trades. You could do, I guess I pick a bad example, but you could find a good trade. If you look for this, you could just go crazy, you know, just start looking for things and looking for good trades. Remember, the cumulative distribution is the probability of something at that level or less. If you want to compute the probability for something at the level or higher, you have to do the complement. So you have to do 1 minus that probability. So you have to complement. So anyway, so that's it. That's how Ultra works, no? Will you start posting official trades with this new net? That's a couple questions. So yes, I have 3 trades that are tests for tomorrow. I don't know, you know, it seems it's going to be 2 failures, 1 success, but it's okay. You know, it's just all about edges. And yes, I will use this. If I see an attractive trade, we'll use it. I know the Sigma 2 trades are actually very attractive, and I'll start using them. If I see really good edge for the Sigma 2, I might use the lower portion as official trades. So and I have other tools. I have the SKU trade uses a complete different system. So I have systems that complement each other. But don't worry, if I can find something that is good, I can find something that that delivers good edge, I'll post it. So that's everything I have from here with custom trades and with trading the targets. If you have any questions, please, this is the time for questions. This is just go crazy before I end the transmission. Otherwise, we can see questions on the room. We can follow the discussion. But I wanted to give you at least a feel of what the new nets were doing, what the probability distribution is, and the best ways to play it. Okay, a good question. When do you suggest to put on the trade? The day the signal is generated? Depends on the premium, near the close. So, of course, so from the table, remember the way all of the neural nets were trained is they were trained with closing values. So values at the end of the day. So the closer we are to the last minute of the day, the better. I will wait for a solid prediction. I will wait until 355, 356. I don't think the 5 minutes will change this too much. So yes, I will wait for that. And there is always the option of doing all trades. This is something that the Gamma Optimizer members are really good at. I have noticed that some people are really good. That's why I showed the table with all data. And one of the reasons I show is because you could find, I don't know, opportunities from all predictions. Tomorrow we have interesting predictions for tomorrow, and maybe you can start looking at tomorrow at this row and find something. Or even for Monday, this is for Monday, and you could say, okay, there are some predictions here. Is there anything I can do here? Is there anything with good edge? So that's what I showed them. So it's up to you. So sometimes I'll do it just for fun. If the prediction is really cheap, and I'll take it, and if there is good edge on it, I'll play it. I have a question. Do options dealers expect the mean to be slightly up, or do they have expectations about direction as well? Yes, option dealers, truly they don't care about the mean of the distributions. Options, when you do option pricing, I don't know if I am showing this. I hope I am showing the right window. I have so many windows that I don't know what I'm showing. So the neural net is predicting mean and standard deviation, no? So option dealers don't care about the mean. Option dealers only care about the standard deviation. So all of the systems they have, every single system they have, they use, even if they use neural nets or if they use whatever thing they use, super advanced, they are predicting only volatility, because option dealers don't care about the mean. They don't have delta risk. They don't have gamma risk per se. They don't have directional risk, so they don't care about the mean. They always assume that the mean is 0, and they only care about volatility. Why 5 days for predictions? Well, because those are really advanced nets. I do have neural nets for arbitrary periods, no? So the answer is yes. You could use a neural net for any period, but I'm just sharing this net with you guys. No, it's one of this is a really ultra proprietary thing that I share for the gamma optimizer, and I like 5 days because it's a good time frame, and it's also historical. No, we used to have only weekly options. It's only lately that we have options expiring 3 times a week, and probably soon we're going to have options expiring 5 times a week. So initially, when I started all this work many years ago, it was weekly. But if you go even farther back, you will see once a month. So that's kind of why the time frames are kind of arbitrary. Sometimes in the future, could you review how to compute log functions? Use a couple of examples. Well, the log is just the logarithm, no? But yes, I could review log return. So I could do something on how to compute a log return. It's not hard. It's just the logarithm of the final value divided by the starting value, the natural logarithm. Okay. So, okay, folks, thank you very much. Thank you for attending the presentation. It has been really fun. I hope that at least it's more clear than before, and that we can continue the discussion in the room, but at least you get a sense of what the nets are doing, and hopefully with this we can design more trades. I have another question. What are your thoughts on designing trades to maximize peak Kelly? Is there a sweet spot in terms of probability and option cost that can be calculated? That's really interesting, Sam. A priori is impossible. We don't know. For instance, today options started to becoming really juicy around the morning because option dealers were really worried, but then option premium disappears, so it changes all day long. That's the thing. It's so hard to do because the prices of the options are changing constantly. So yeah, you just take a look at this, and we can continue. I can do a second video. At least this is an introductory video, gives you a feeling of what we are seeing, and it removes a little bit of confusion and clutter. Now, if you only want to see normal predictions, focus on the first row, forget about the rest, and let's play. We should do some statistics review. I guess that's the class. But in any case, I already took like 1 hour on this, so it's long enough. So thank you very much again. I hope that you have a great rest of the day. Take care, folks. Bye-bye.